In Essential Task 1.7, we are going to outline some of the basic steps involved in the memory process. And then later on in Essential Task 1.8 and 1.9, we are going to be talking about some of the things that influence forgetting, memory retention, ways to improve your memory. So we will begin the actual concept map at the very top, underneath Information Processing Model. The purpose of this is to outline sort of in a sequential time frame how memory works. The very first step in memory here is at the very top of your concept map labeled sensory memory. It's really hard to identify or notice sensory memory at any given moment. If you were in class, there was sort of a very quick demo that we do, and I'll try and describe that demo in just a moment. But there are two different types of sensory memories. They are both identified as sensory registers. So if you're talking sort of broadly, we call this sensory memory, but there are some more specific terms that we'll identify in a moment. But sensory memory is that first couple seconds that you interact with, whether it's a visual or a sound, before it ever really reaches your long-term memory. It's there for a split second and then it's gone. So for example, if I flashed a sequence of numbers in front of you and it was only on the board for truly a split second, you might remember one or two of the numbers or letters, but the rest are just going to vanish. You didn't have enough time to truly interact with that material to form any substantial form of memory. We call that split second, and I mean, I'm really talking about seconds here, that split second visual capture that you may have had of all those numbers and letters flashed in front of you. One example of what's called a sensory register. In that case, an iconic memory. So a very brief visual memory. Alternatively, there's also what we call echoic or auditory memories. The best example of this would be any time in class where the teacher calls on you, you weren't really paying a lot of attention. However, you're able to capture the last second or two and answer to the best of your ability just based on that last second or two. That's a great example of the active nature of your memory, even if you're not giving a ton of attention, in this case to the teacher, or maybe perhaps to your parent or guardians. So if letters or numbers are flashed on the screen and you're able to remember very briefly one of them or two of them, that's iconic memory. If you've ever been called on when you're not really paying attention, but you can remember the last moment or so, truly the last second or so, that's what we call an echoic memory. Again, the letter M stands for mnemonic, and I've isolated the word icon and echo so that you can connect visual and auditory to each of those. So we're going to zoom back out and we're going to progress forward into the concept map. So let's say after that split second, you did choose to give that information your attention. So we're talking about reading a textbook, watching these slides. We're going to then proceed on the assumption that you are in fact engaging with the material and you are focused. Because if you're not focused on the material, that material is never going to make it to these steps. So I flashed 10 numbers in front of you and you remembered one. Those other numbers are gone forever. They've never really entered into the memory process. However, if material does in fact enter the memory process, we proceed to the very first stage, and we call that encoding. Encoding is the very first time that you interact with material. In a perfect world, you're encoding this slide right now. But the first time you read a textbook, the first time you look at new vocabulary, the first time you're sitting in class watching your math teacher provide an example, you're undergoing the process of encoding. Just because you read or listen or watch doesn't necessarily mean that this process was effective. You could have been sitting in a class listening to a teacher and then gone home that night and been unable to complete your homework. And you're sitting there thinking to yourself, I listened to this teacher for 20 minutes. I just have no recollection of what I was told. My long-term memory seems to be empty. Under those circumstances, it's likely that you're experiencing what's called an encoding failure, meaning you didn't pay enough attention, or the manner in which you were listening wasn't super effective, or perhaps just the technique to deliver the information wasn't effective. And as a result, that information never really made it to your long-term memory. It's not even there to remember when you're at home doing your homework. That moment of encoding is really pivotal, and it's a moment we're going to revisit as we proceed with some of the memory demos throughout this unit. But assuming that you did in fact engage and encode the information effectively, so you were paying attention, you were listening, you can then proceed onward in the memory process. We have 4 remaining boxes in this concept map. We just finished here under the yes. And again, that yes stands for yes, we did pay enough attention to the material. Short-term memory is sometimes called working memory and is often abbreviated STM. Short-term memory is easily one of the most misunderstood topics that we talk about all year. once we talk about it, we'll understand it. But just the average person on the street very often uses the term short-term memory incorrectly. And hopefully over the course of the next 10 minutes or so, we can really hammer home precisely what short-term memory is. One of the unique aspects of short-term memory, which is really pivotal, is to know that short-term memory is only the information that you have engaged with for the last 20 to 30 seconds. That's it. So, for example, what you had for dinner last night, although it's fairly recent relative to the rest of the events in your life, because it's happened longer than 20 to 30 seconds ago, it's technically not short-term memory. That's already in what we call long-term memory. The same is true for what you learned in class today or what you've recently learned in school. That information, because it didn't happen 20 to 30 seconds ago, is not considered short-term memory. Short-term memory is only the material that you have engaged with. So right now, the only material in your short-term memory is really the length of short-term memory. If we just spent 10 seconds, 15 seconds, 20 seconds, or 30 seconds in that range talking about presidents, and now we start thinking about George Washington and Abraham Lincoln, now all of a sudden those presidents are in that 20 to 30 second window. And after that 30 seconds is up, the next 30 seconds takes place. So it's really pivotal. When somebody says, I have poor short-term memory, it's probably not true. If you forget what you learned yesterday, that's more a failure of long-term memory, or maybe even potentially a failure at the encoding process. What I'd like you to do now, if you're engaging with this at home, is take out a piece of paper. You can flip your concept map on the back, but we're going to engage in a very brief demonstration of just how much information you can put into your short-term memory. So if you're at home, we're going to engage in our first demonstration, remote demonstration. I'm going to say a series of 6 numbers. I want you to just listen to the best of your ability to those numbers. At the very end of those numbers, I'm going to ask you on a scrap piece of paper on the back of your concept map to write down as many as you can remember in order. 4, 7, 3, 2, 1, 5. Please pause the video. Try to write down as many as you can remember right now. So if you found that to be overwhelming, that wouldn't be too outlandish or outrageous. 6 numbers can sometimes be challenging. Before we proceed onward, though, I am going to try this one more time. So we're going to do the exact same procedure. Instead, though, we're going to do 8 numbers. So I'm going to up the ante a little bit. So we're going to do the exact same thing in just a moment. So again, you're just listening. You're not writing anything down until I tell you to pause the video. 8, 9, 1, 4, 7, 3, 6, 8. Pause the video and write down as many as you can. So if you found that second trial to be quite a bit more difficult than the first, that's totally understandable. That's because your short-term memory is limited by what we call 5 to 9 bits of information, meaning at any given moment, you can only keep 5 to 9 bits of information within that 20 to 30 second window of time. So that first trial, which was 6 bits, falls right into that range. 8 is about the outer limits, though. If we were in class, we would continue this. We would try a trial with 12 numbers and even more than that. Occasionally, students using a technique or two can sometimes expand that. But in terms of raw individual information, it was discovered in the 1950s by George Miller that the capacity of your short-term memory is 5 to 9 bits of information. I use that word bits intentionally. If we were to redo that demonstration, and instead of 8, 9, you tried to group that together as 89, you would actually be able to expand the raw numbers that you could put within your short-term memory, where instead of 8, 9 taking up 2 bits, 89 takes up a single bit. We'll talk more about what we call chunking in a later goal, but that word bit under the capacity line is there on purpose. George Miller, though, gets a contributing psychologist logo, so he could appear on the AP exam, but he's not an overwhelmingly important name. This is one aspect of the history of psychology. That's what the history logo indicates. And that's what we just did. We just indicated in our demonstration the capacity of short-term memory. Typically, when you see this transition, that means we've just done a demo. Some students over the course of the year put little D icons next to the topics that we had demos for. So whether you're in person or remote, putting a letter D next to the term short-term memory could help at the end of the year recall that we did in fact have a demo for this term. Proceeding onward, there are only 3 more steps involved in this essential task. So now we've encoded information. That information is likely in our short-term memory. So the information that we just talked about with George A. Miller might still be there because I just reminded you of him. He's probably jumped back in for another 20 to 30 seconds. The next very quick term is what we call storage. Often, as much as possible, we'll try to use sort of the proper terminology that cognitive psychologists studying memory use. Often, what people consider long-term memory or previous memories, memories that have been effectively encoded, are classified as being stored away or in storage. It's kind of like your Google Docs. At any given moment, I could ask you who the first president is. You would then jump into your storage, pull out George Washington. George Washington would hang out in your short-term memory for 20 to 30 seconds. But you first pulled him out of what we call storage. A synonym of storage is what we call long-term memory. This is the furthest to the bottom this essential task goes. So to zoom out, we're currently right here, and then we're going to end with one more box after this. Long-term memory is sometimes abbreviated LTM. Long-term memory is basically everything else. So if it wasn't the last 20 to 30 seconds, it's classified as long-term memory. So that means all of the factual information you've ever learned, all of your life experiences, your motor movements, so how to ride a bike, how to throw a baseball, how to drive, all of that information is classified under long-term memory. We're going to talk more about the specific types of long-term memory in the following goal. Currently, there is no known capacity to your long-term memory. It's basically everything that's existed outside of the 30-second window that your short-term memory includes. So every life experience is in long-term memory, and at least as of right now, unlike short-term memory, there's no raw capacity. Again, short-term memory is stuck at 5 to 9. We don't have any definitive number for long-term memory. The final box, all the way over here on the right. So we're kind of doing the circle motion where information is encoded. It's kind of hanging out in short-term memory. Assuming you encoded it effectively and you're not experiencing encoding failure, it was stored away. So, sort of another word for that's your long-term memory. The proper word for remembering is retrieval. I'll try as much as possible to use that word retrieval. But the process of taking something out of long-term memory or out of storage, depending on what term you're using, is the process of retrieval. So a few moments ago when I asked you who the first president was, you underwent the retrieval process where you pulled that information out of your long-term memory or your storage, provided that information, and now that information is going to wander back into your storage until the next time you need to undergo the retrieval process.